Hi class, how are... Oh, well, you could let me finish. Okay, moving on. The learning target for today is to prove that two lines are parallel. So last time we talked about if you have parallel lines, you can figure out certain pairs and whether or not those pairs are congruent or supplementary to each other. Now we're going to do the opposite and look at those pairs and prove whether or not two lines are parallel. Alright, so here are a bunch of theorems about parallel lines. The first four, the four that are in blue, we've sort of already talked about, although I didn't name them as theorems. So, corresponding angles, alternate interior angles, alternate exterior angles, and interiors on the same side, or as I said, same side interiors. Those all have their rules. The corresponding and the alternates are all congruent. The same side interiors, and it doesn't have the same side exteriors here, but that's also true, those are supplementary. So the thing I want to talk about today are the converses, the ones in white, all these converses. So the blue ones say that if you have two parallel lines, then the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent, and the same side interior and exterior are supplementary. The converses say it in the other direction. They say, using the corresponding for example, if two lines are cut by a transversal and the corresponding are congruent, then the lines are parallel. So, instead of assuming that we already start off with parallel lines, we're now saying if you have two lines cut by a transversal and the corresponding angles are congruent, then those lines are parallel. And that's also true with the alternate interior and the alternate exterior. And the same side interiors are that if two lines are cut by a transversal and the same side interiors are supplementary, then the lines are parallel. So pretty much what this is saying is if the rules that we've been doing with parallel lines work, then those lines are parallel lines. So make sure to write these down because they're very important. I took this image off the internet, so you should probably put the blue ones together and the white ones together. The blue ones are the regular and the white ones are the converse. And the converses are the ones that we're going to be talking about. Alright, so here's an example. As usual, don't mind my drawing, I'm a terrible artist. So, determine which lines, if any, are parallel. So, we have some measurements here, and we want to use those measurements, along with the theorems we just talked about, to be able to determine which of these lines, if any, are parallel. First thing I look at when I see this is I see a triangle right here. Triangle BDF. And in that triangle we have two angles, 65 degrees and 55 degrees. So using that we can find the third angle. We just say 55 plus 65, which is 120, and then say 180 minus that, which is 60. So this angle right here is 60 degrees. Well, we now notice that this angle is 60 degrees, and this is also 60 degrees. So those two are congruent, which means we might be able to use those to prove that two lines are parallel. So let's look at this. It's always good to extend your lines out a little bit. So let's extend this line out just a bit. And so now, in this area right here, if these were parallel, then we'd be looking at these two angles here, and this angle is in the upper right hand corner, and down here this angle is in the upper right hand corner. So they're in the same spot in two different pictures. That means those two angles are corresponding angles. So we know that angle BDF is congruent to angle DGH, and that's because they are corresponding angles. You can abbreviate. So because of that, we know that those two angles are congruent because they're corresponding. So the two lines that they are related to are parallel because of the corresponding angle theorem. So this line right here, line DF, is parallel to this line right here. Remember, two vertical lines to say that they're parallel is parallel to line GH. So we know that those two are parallel. Awesome. Now let's see if the other two are parallel. Let's see if AB is parallel to those as well. So another thing I look at is we see that this angle right here is 55 degrees and this angle right here is 55 degrees. Well, 55 plus 55 will give us 110, and those three angles here make a line. So that means 180 minus those two angles will give us the third angle, which is 70. So we know this right here is 70. So now, if we are trying to see if these two are parallel, if these two lines are parallel and this is the transversal we're talking about, then this angle right here is 65 degrees and this one is 70. These are both on the interior of the parallel lines. They're both inside the parallel lines, but they're on opposite sides of the transversal, alternate sides. So these two are alternate interior angles. So if they're alternate interior angles and these two lines were parallel, then these should be congruent. However, this angle is 65 and this is 70. So that means they're not congruent. So that means these two lines are not parallel. So AB and DF are not parallel to each other. So to answer this question, the only two lines that are parallel are DF and GH. Alright, here's another kind of example, and we're going to be dealing with these quite a bit from now on. This is what's called a proof. So in this problem, we are given a couple things. We are given that line R is parallel to line S. So R and S, these two lines are parallel, and they're even marked with these arrows. So R and S are parallel. And they also say angle 5 is congruent to angle 6. So angle 5 here is congruent to angle 6. So these two are the same. Using that information, they want you to prove that line L is parallel to line M. So they want to know that these two lines, line L and line M, are also parallel. To do this, we're going to do what's called a two-column proof. So in the two-column proof, you have two parts. You have the statements and you have the reasons. So the statements is things you say that are true. The reasons are why they're true. So the first thing we always start with is our given, the stuff that's given to us. So that R is parallel to S and angle 5 is congruent to angle 6. So we write that those two things are true, and our reason is because it was given to us. It's prior knowledge. So we just write given. So it's told to us, that's our reason for saying that it's true. Then the rest of it, we have to go into this problem and figure out things that are true that will help us get to what we want, which is to prove that L is parallel to M. Just a quick note, because I know some people are thinking this. 4, 5, 6, and 7, those are the names of the angles. Those are not the measurements of the angles. Just the names, not the measurements. It would have to have a degree to be the measurement. All right, so to get this started, we know that these two lines are parallel here. So that means in the transversal, this transversal right here, we can find things about all the angles in this attached to this transversal and these parallel lines. So we can use same side interior angles, alternate interior angles, corresponding angles, all of those. So the two angles that were actually given names are angle 4 and angle 5. So what do we know about angle 4 and angle 5? Well, they're both in between the two parallel lines, and they're on the same side of the transversal. So those are same side interior angles. And what do we know about same side interior angles? They're supplementary. They add to 180 degrees. So we can now say in one of our statements that angle 4 and angle 5 are supplementary, and so adding them together will give us 180 degrees. And we know that because of same side interior angles. And I'll abbreviate for room. So we know that those two angles are supplementary, so they add to 180 degrees. Now, let's introduce the other transversal and see if we can get these two to be parallel. So we were dealing with this one. Now let's connect it to this one over here. So we know that 4 and 5 are supplementary. They add to 180 degrees. So now we can take angle 5 and angle 6, and we know that those two are congruent. They're equal to each other. Well, if we know that they're congruent, well, we've said here that angle 4 plus angle 5 is 180 degrees. If 5 and 6 are congruent, we can replace angle 5 with angle 6 and say that angle 4 plus angle 6 is 180 degrees. And we know that because we know that angle 5 is congruent to angle 6. So now we just proved that angle 4 and angle 6 are supplementary angles. So, if they're supplementary, and they're attached to two different parallel lines, two different lines that we want to be parallel at least, that means we might be able to see if there's a theorem attached to them being supplementary. Well, if we look at these two lines, and we want them to be parallel, then angle 4 and angle 6 are in between these two lines, and they're on the same side of the transversal. So they are same side interior angles. And we know back from the theorem I brought up before that if same side interior angles are supplementary, then the two lines are parallel. So, we just proved they're parallel. Those two lines are parallel. So let's say our final statement. Our final statement is that they are parallel. So L is parallel to M, which is what we were looking for. That's our final statement. That's what we proved. And our reason is the theorem, which states if same side interior angles are supplementary, then the lines are parallel. And we're done. We have proved that line L is parallel to line M. And we're finished. We'll be doing these kinds of proofs a lot with parallel lines, and we'll go into even more after this. But that's it for right now. Remember, please take notes on the entire section, and please take a picture of your notes right now and submit them to eBackpack. Thank you. Have a good night.